In this segment, we're going to talk about energy transport. Let's first look at the law of energy transport. The law of energy transport states that energy must flow from hot regions to cool regions. And there are three ways you can transport energy: by conduction, by convection, or by radiation. Let's first look at conduction. Conduction is a mode of energy transport where thermal energy is transferred by the direct contact of a warmer material to a cooler material. The key words here are direct contact. Here we are looking at a cartoon from your textbook, and we have a candle that has an open flame. That flame produces heat, and that heat is going to heat up the spoon. The spoon is made of metal. The roundish end is going to heat up and get warm. The opposite end of the spoon, where you hold it, is the cooler material. The entire metal spoon is the material, but the end that's being heated up is warmer, and the end that is out furthest away from the flame is cooler. Now you cannot see the energy transport. So it's very important for you to remember that you cannot see this energy transport. Your eyes cannot see the energy being transported from the warmer end of the material to the cooler end of the material. But heat will flow through the material from the agitation of the particles in the material, and it will flow from the warm end down to the cool end until finally reaching this cool end, or the handle end. Now, if you held this metal spoon at the handle over the open flame long enough, you would feel the cooler end, the part that you're holding, you would feel it heat up. So you know conduction is occurring. You know it by feel, but not by seeing. Let's move on to convection. Convection is also a mode of energy transport. Convection involves movement of hot or less dense material that rises and cooler, more dense material that sinks, producing a continuous circulation and thus a transfer of heat. Let's look at water. Let's say you have your pot of water and it's sitting on an electric stove. You have the electric burner turned on, and that burner flames up to the color red. Now, have you ever watched a pot of water boil? First thing you notice is that you develop bubbles on the bottom of the pot. So I drew blue dots to show these bubbles. The next thing you notice is that the bubbles rise to the surface. And when they reach the top, they pop. The bubble is a gas bubble, and so it rises, and when it reaches the top, it releases the gas into the atmosphere. Now the material at the bottom of the pot gets warm, whereas the material at the top of the pot still remains colder compared to the water at the bottom of the pot. And so you have this movement of these bubbles, and the movement is transferring heat from the bottom of the pot to the top of the pot. Now the water at the top of the pot is more dense, it's colder and more dense than the water at the bottom of the pot. So you have this colder material dropping to the bottom of the pot, while you have this warmer material rising to the top of the pot. Eventually you get this rolling boil, where the warm material from the bottom of the pot rises to the top of the pot, and the colder, more dense material at the top of the pot sinks down to the bottom of the pot, causing the water to boil. This is the only mode of energy transport that you can actually see movement of material. In this case, a rolling boil of water. Let's look at another example. In this example, this cartoon from your textbook, we have an open flame candle. And what we see is these red lines and blue lines making circular motions above it. What is actually moving? In this case, you have the gas that's moving right above the flame. So the air near the flame becomes warm. And the cartoon in your textbooks colors this warm air as red. And this warm air is less dense and it rises. So you see the lines going up. Now the air at the top is much cooler, and they've colored this air blue. And so that cooler air is more dense than the warm hot air. The warm hot air creates a region of low pressure down at where the flame is. And so this colder, more dense air sinks down to fill the void where the low pressure is. So you have hot air rising, followed by cool air sinking. More dense air rises, less dense air rises, creating this circulation called convection of this air. Let's move on to radiation. Radiation is another mode of energy transport. In this case, energy is being emitted by a body, and that energy is being transferred through an intervening medium such as air or through space, and it is absorbed by another body. In this example from your textbook, we see an open flame, and this open flame is an energy source. It is creating energy that is being emitted from the flame. It is generating energy from this flame, and that energy you see as these red squiggly lines. And the energy is being transported away from the body through the intervening medium, which in this case is the air around the candle. Now we don't see in the cartoon another body that is going to absorb the energy, but let's just say you stuck your hand out here. If you got your hand a few inches away from the flame, you might feel that energy transport. You might feel the heat from the candle. Here's another example where you cannot see the energy being transported. You can feel it, but you can't see it. There are only 3 modes of energy transport: conduction of heat through a metal spoon from a hot region to a cool region, radiation, that is energy that is emanating from the open flame as waves or particles that you might feel as heat if you had your hand a few inches away from the open flame, and convection, where you have this rolling motion of gases around the open source of flame. Of the 3 modes of energy transport, only 2 are inside the sun. Here we have a cutaway of the sun. Energy is being generated in the interior of the sun, in the core, and the energy is being transported outward by photons that follow a random path as a drift, that's outward drift. And it transports through this zone called the radiative zone. So the interior to about 2/3 the way out, from the center to 2/3 the way out, is the radiative zone. There is no mass motions of material moving. You can't see this energy being transported. Only in the last 1/3 region will you see material moving, and that is in our convective zone. In the convective zone, you have hot material gases rising, which the cartoon uses as the red color. So you see these red lines indicating the mass motions of material moving upwards. It's hot, less dense material moving upwards, and the cool, more dense material sinks down to the bottom of the convective zone to be heated up by the radiative transport of energy, transporting that energy to the surface. So you see the outer 1/3 is in this rolling boil of gases called convection. Not all stars act like the sun, where you have the radiative zone on the inside, in this cartoon is colored orange, and you have the convective zone on the outside, which is colored yellow. Stars that are 7 times more massive than the Sun have the opposite. The radiative zone is on the outer portions of the interior of the star, whereas the convective zone, or the rolling boil, is on the interior portion of the star, closest to the core of the star. Stars that are very small, like the 0.2 solar mass star, doesn't have any radiative zone at all. Notice the interior is just colored this orange. All you have is convection. The entire star is fully convective in the interior. So not all stars have both radiative and convective zones. Some only have one, such as the convective zone.